Hi guys, last week we talked about right triangle trigonometry, and this week we're going to talk all about angles and the unit circle. And then the last thing we're going to do together next week will be to put together that right triangle trig on our angles, on our unit circle with different kinds of angles. So we're going to start today talking about the different kinds of angles that you already know from geometry and middle school. So just a quick review. An angle is formed by two rays that share an endpoint. We call those two rays, we call them the sides of the angle. And then the endpoint that they share is called the vertex of the angle. And we use this Greek letter theta, and that's how we say it. It's a circle with a little horizontal line, and we say theta. And we measure angles according to the rotation from one side, that's one ray, to the other side, and we usually do it in degrees. That's what we're accustomed to. So types of angles are acute angles, which are between 0 and 90 degrees. And you can see here that this is one side. I'm going to rotate up counterclockwise for this other side, and our angle here is between 0 and 90 degrees. That's called an acute angle. If our angle, we rotate from this side up to this side, and it forms a right angle, then that's a 90-degree angle. If we go from here beyond the right angle, somewhere between the 90 degrees and 180 degrees, that's called an obtuse angle. And then if I go all the way from this side, I rotate all the way through and I end over here. This creates what we call like a half circle. The angle itself is called a straight angle because it makes a straight line, but it's got a measure of 180 degrees because it does have this vertex here. It's one side of the angle rotating all the way through to what we call an opposite ray, and that creates what we call a straight angle, and it's 180 degrees. Okay, so now we're going to talk about circles a little bit. We reviewed angles. We're going to review what you already know about circles, and then we're going to put it all together to create something new about angles. So I'm going to remind you that the circumference of the circle is the distance all the way around the circle. And the formula for that circumference is 2 times pi times the radius of the circle. And the radius of the circle is defined as the distance from the center of the circle out to any point on that circle. It's a consistent distance from the center of the circle out to any point that's actually on the circle. So there are 2 pi of these radiuses that go all the way around from a starting point and to end where it started. So that's where we're going to introduce this new idea about measuring angles a different way other than the 360-degree circle that we're used to. So that idea of the full rotation all the way around a circle of being 360 degrees is a human construct. It's man-made. It's not natural or inherent to the circle. It's just a decision that somebody made once and we all followed along. The radian is a more natural way to measure the rotation of an angle in a circle, and 1 radian, I'm going to show you, is going to be equal to the distance from the center out here is called our radius. And so we're going to use this radius to define a rotation of an angle called the radian. So let's talk for a minute. So a full rotation, you all know, as 360 degrees. And think about it. So I'm going to take this piece of rubber band here that is equal to the radius of my circle. So its length is the radius of my circle. That's a straight measurement. And I'm going to take this, and instead of using it from one point straight to another point, I'm going to bend it around my circle. And it's going to end about here. And so this rotation from here to here, where my arc length is exactly the same as my radius, this rotation is going to be called 1 radian. And so I would keep that up to show you, right, that so from here to here, that's my second radian. So now I have 2 radians that I'm opened up to. Right, because my angle starts here, I'm going to go up to here is 1 radian, and then over to here is going to be 2. And then I'll do another one. This is the length of the radius, right? And so here's another one. This is my third one. So that's 3 radians. Okay, I'll go from here to there. It's going to be, this is my 4th radian. And then my 5th. We'll go from here to there. Right, so you'll see there, that's a 5th radian. And this one is 6. And then it's going to end here. And I've got this little bit left over, right here. So it's not a whole perfect number of radiuses, right, or radii that'll fit around my circle. So let's talk about that. So notice that I had 1, 2, 3, and a little bit more. And the value of pi is 3 and a little bit more. It's 3.1417, blah, blah, blah. Okay, and if I had 2 pi's around the entire circle, that would be 2 times 3.14, blah, blah, blah. It would be about 6.28. So notice that's how many of these radiuses, right? This is 1 radius, and I could fit 6 and a little bit more. So that's that 6.28. 3, 4, we just keep going, right? So, 360 degrees, a full rotation in degrees is the same as 2 pi radians, right? And we're going to call it a radian because I'm not measuring that straight distance from the center to the circle. I'm measuring the opening or rotation of the angle when the arc length is equal to that radius. So we call the angle measurement a radian. A distance is called the radius. So although they're related and they sound very similar, one measures an angle, the other measures the distance from the center out to the circle. Okay, so one full rotation, which we know as 360 degrees, we are now redefining as 2 pi radians. This is a different way to measure our angles. So if I'm only going to go half a rotation, let's go halfway around my circle, then notice I would cut this 360 degrees in half. That'd be 180 degrees. And we talked about that up here, how it's kind of half a circle. And so we'll cut this 2 pi in half. That's going to be 1 pi. Then, and you can see that here, the number of radiuses, right, bent radiuses around the top half of this circle was 1, 2, 3, and this little bit more that would be equal to that 0.14, blah, 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 that is pi. So we're going to use this ratio. We're going to come down here and we're going to talk about how we can convert between angles that we're comfortable with in degrees to radian angle measurements, because this is going to help us do some mathematics later. We're going to need the natural way to measure an angle rather than this man-made construct. So I'll come down here and let's just think about it. So this isn't how you're going to do it every time, but I want you to think about it. So if I have an angle of 30 degrees, I can compare it to half a circle of 180 degrees. The same way, I want to know the angle measure that 30 is in radians, so I'm going to put this unknown theta up here, right? That's what I don't know, is the radian measure that's equal to. But it's got the same ratio to pi as 30 degrees has to 180 degrees. Okay, and then we can just multiply, cross multiply if you want, or we can just multiply both sides of this equation by pi. Right, so these pi's will cancel out. So this theta that I need to know the measurement of is going to be the original angle that they gave me in degrees times pi over 180 degrees. This ratio of pi to 180 is equivalent to 1, right? So we're going to change the 30 degrees to radians by multiplying it by this ratio that's something really divided by itself. They're just in different units, radian units to degrees. So what that does for us, I want you to notice that the degree units will also cancel out. And I've got this 30 to 180. I'm going to reduce this fraction. They both, the numerator and the denominator, have a factor of 30. So 30 divided by 30 is 1. And 180 divided by 30, you can do in a calculator, is 6. And then times this pi. So we say that this 30-degree angle is the same as pi over 6 radians. Now, we don't usually write the word radians. If there's no degree measure symbol here, then we assume that it's in radian measures. We just assume radians. We don't have to actually write it. Again, because it's natural to the circle. Okay, so what did we do here? We divided by 180, we multiplied by pi. So we're going to do that here. We're going to take this 135, to convert it to radians, we're going to multiply by pi and divide by 180 degrees. We're going to see that the degrees cancel, and we just need to reduce these two numbers, the numerator and the denominator. And so when I look at 135, I know that 45 will go in there. So I'm going to use my calculator, right? And I'm going to do 135 divided by 45. So 45 is a factor of 135. And I might be able to reduce this even more. I'm just doing this right now in my head. So well, with my calculator here, 27 times pi over, and then let's see, 180 divided by that same factor of 45 is 36. Now notice I can still reduce this even more. So 27 and 36 both have a factor of 9. So 9 goes into 27 3 times, and 9 goes into 36 4. So 135 degrees is the same as 3 pi over 4, we say, 3 pi over 4 radians. And again, we don't have to write this word. It's implied. The degrees canceled out. It's implied that those are in radians. So the process that you're going to use when you go from degrees to radians is to multiply by pi, divide by 180. We can see that these are going to cancel out. 180 degrees is the same as pi radians, and we saw that up here when we saw the 3 and a little bit more, and we found it here. Okay, so going in the other direction is a lot easier if I already have a pi involved in my radian measure, right? So again, if converting from degrees to radians, I multiplied by pi and divided by 180. Over here, I'm going to go in the other direction. So let me just write it for a minute the way we did it here, and then we'll talk about how we'll do it in the future. So pi thirds radians is to 1 pi, that's a ratio, as the degree measure now that I'd like to know is to 180 degrees. So I'll come here, and I want theta all alone, so I'll multiply this side of my equation by 180 degrees. I multiply this side of my equation by 180 degrees, and then we see that the theta, right, because this is going to cancel, so this theta is going to be equal to 180 times this radian measure divided by pi. So this pi divided by this pi will be 1. It's going to cancel out. And so I'm left with 180 degrees divided by 3 here, 180 degrees here, and then we still have divided by 3. The radians are gone because this was a radian measure as well. So again, these units are going to cancel, and I'm going to be left with this degree measure. So 180 degrees divided by 3 is 60 degrees. And that's the equivalent degree measure to pi over 3 radian measure. Okay, so again, we're not going to set it up like a ratio and do all this crossing out all the time. What we're going to remember is that when we take this radian measure, 5 pi over 3, we're going to multiply by 180. Well, let me do that in a different color. We're going to multiply by 180 and divide by pi. And so the pi's are going to cancel. The 180 degrees can be divided by this 3, and we'd get 60. We saw that over here. And then times 5. So 60 times 5 is going to be 300 degrees. The degree measures stay. So again, we've got this 2 pi here. The process is gonna be multiply by 180 and divide by pi. That's gonna be how we're gonna convert. It's the opposite or reciprocal of what we did up here. Up here we did pi over 180. Here we do 180 over pi. We're gonna see that the pi's are gonna cancel, and 2 times 180 degrees is 360 degrees, which is a full rotation around the circle. 2 pi is a full rotation around the circle. We talked about it right there. Okay, so let's go to page 2. So let's talk about angles and standard position. So you may have noticed on the front page that I kept starting at the x-axis. So let's talk about that. We're going to start. All of our angles in standard position are going to have their initial side at the positive x-axis, and the vertex is going to be at the origin of this x and y axis, and the terminal side is going to be the other way. So this is a new vocabulary word, terminal side, and we're going to use it, right, a lot. So terminal side is the one that's not this initial side that starts at the positive x-axis. So at the positive x-axis is 0, and then we're going to rotate for positive angles. We're going to rotate up in a counterclockwise position. So we're going to rotate up, and then wherever we stop, that's called the terminal side right here. If our angle measures are negative, like they are right here, that negative sign is going to indicate that we should rotate in a clockwise position. In other words, we're headed down, right, which is the negative direction, down and around in a clockwise position. And then our terminal side would be somewhere in that direction. These arrows help indicate to us whether we're going in a positive direction up from the initial side or a negative direction down from the initial side. So let's see. So if I start here on this positive x-axis is 0 degrees, and I rotate up because it's a positive 45, I remember this is 90 degrees. It's a right angle. Half of that is going to be so this would be an angle of 45 degrees. It's exactly half of the 90 degree angle. It's always got to start here on the positive x. Okay, so now let's look at a positive 225. So I'm here at 0 degrees. This is 90 degrees. Every time I go another quarter of the coordinate plane, right? So I'm going to go another quarter, I get 180 degrees. This one's going to be 270 degrees. This 225 is going to fall somewhere between there, right? Actually, it turns out that it's going to fall perfectly in the middle of 180. It's 45 degrees more than 180, 45 degrees less than 270. So we're going to indicate this angle in standard position by starting at the initial side, and it's positive, so we rotate up and around to here. This angle stops at 220. It's 225 degrees total from this initial side. Okay, so we're here at 0 degrees. This negative tells me to go in the opposite direction. So if I went from here in the opposite direction down, this would be negative 90. This would be negative 180. I want to go negative 135 degrees. So I'm going to go negative 90 and then another 45 degrees, which is going to put me smack dab in the middle of this quadrant. And the arrow indicates that I went in a negative direction from my initial side down in a negative direction. So this angle's measure is a negative 135. Okay, so it gets a little less comfortable for everybody when we start doing it in radians. So I'm going to just talk about what we see here for just a minute. So here we have 0 radians because this is my initial side. I haven't rotated at all. Okay, we already know that halfway around my circle is pi radians, and if I come all the way back around, I end up at 2 pi for a full rotation around. Well, so let's talk. If I only go half of the way to pi, that would be a pi over 2, would be my rotation from 0 up to half of pi. But we want pi over 4, which is half of a half. So 1/4 of the way from 0 to pi is right here, just like this angle was. So this is a radian measure of pi over 4. Notice it's equivalent to 45 degrees. And that makes sense because this pi is 180 degrees divided by 4 is 45. All right. We saw on the front that 5 pi over 4. Did we do that one? Nope, not yet. Okay, so we'll do it here. So this is 0 radians. We now know this is pi over 2 radians. And then we see that this is pi, if I'm starting here, rotating up in a positive direction, all the way around, this is 2 pi. Okay, well, think about it. If this is pi and I go another pi over 2, because pi over 2 is a quarter of the way around the circle, so I'm going to go another quarter. This 1 pi plus another pi over 2 is 3 pi over 2. Okay, but so here's a little trick that I'll show you. So, but we want to know where 5 pi over 4 is. So let's do this. So let's take our 1 pi and change it to 4 pi over 4. Okay, we'll take this 2 pi and change it to, just multiply by 4 over 4 because we want the same denominators we have here. So 2 pi times 4 over 4 is 8 pi over 4, and that's equivalent to 2 pi, makes sense. Okay, so that would make this one, right? Again, we need common denominators with this guy right here. We want this 4. So multiply by 2 over 2, I'm going to get 6 pi over 4. This is a pi. Okay, so where would 5 pi over 4 land? It's going to land between this 4 pi over 4 and this 6 pi over 4. It's going to be smack dab in the middle here. So this angle is going to start at 0, rotate around, right? Now think about it. If pi over 4 is halfway through this quadrant, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is 5 pi over 4 is that rotation. Okay, so we're going to go in a negative direction. And so we're going to start at 0. And remember, this negative says I'm going to head down. So this is going to be a negative pi over 2 and a negative pi here. So again, I need these denominators to look like 4. So this is going to be a negative multiplied by 2 over 2. Multiply this by 4 over 4. So this is negative 2 pi over 4. I'm wrapping this way, rotating this way, negative 4 pi over 4. Somewhere in the middle is negative 3 pi over 4. So somewhere between those two. So you have to have, right, the initial side is always here. You'll show where the terminal side is, and then you have to show the indication of the arrow, whether it's going in the negative direction, this is down, and this one's up in the positive direction. All right, so we could actually, right, have angles. If we can have negative angles, we can have angles that wrap around more than one time around the circle. So this is 9 pi over 4, and so I'm going to remind you that this 0 here is where we're going to start, and that was the same as, right, when I rotate all the way around 2 pi. But 2 pi is 8 pi over 4 if I write it with the same common denominator. Okay, this is 4 pi over 4, right? And we're going to go up because it's positive. We're going to go up and around, and we're going to rotate all the way to 8 pi over 4, and then we need 9 pi's over 4. So we need another pi over 4. So remember, pi over 4 was halfway through the quadrant, so we're going to go another half through the quadrant here. And this, which looks very similar to this one up here, but because it wrapped all the way around for a whole rotation of 2 pi, which is equivalent to 8 pi over 4, and then yet another pi over 4, this is the standard position. You have to use the arrows to indicate that it's rotated more than one whole rotation. 9 pi over 4 is more than a whole rotation around. Okay, we're going to pause there, and then we'll get to the next part of the notes.